Hello everyone, you are welcome once again to today's lesson. And in today's lesson, we are going to look at the continuation of the solution to the team assignment on the topic, the binomial theory. Stick and stay with me. I'm your usual facilitator, Mr. Hackman. So quickly, let's go and I will walk you through the solution. Okay, and as usual, whilst walking you through the solution, I will address some of your concerns, especially the major ones that came to bear from what your submissions. Okay, so now in the previous lesson, we look at the solutions to questions 1 up to what? Up to 5. Okay, today we are going to continue from 6 and we will end at what the last question, which is question number 10. Okay, all right. So just as you have on your screens, you know the question will be in red and the solution is what we have in black. All right, so as usual, you've been advised anytime you read questions, make it a point to underline the salient point, if any. So quickly, let's do that. If you read the question, we are told the third terms of the expansion, so maybe we underline third terms. Okay, of the expansion. So this expansion, these two binomial expression with the powers there in ascending powers of x. So it means each of the expansions there, okay, are given in ascending powers of x, and we are told are equal. Very critical. Find correct to 3 decimal places the value of p. So you underline, there is a required approximation, so you underline 3 decimal places. What's the value of p? Okay, so now that we've underlined the salient or the critical part of the question, now the first thing that you write is solution. After solution, questions are numbered because we equally want you to number your solution. So solution to question number 6 given, so you extract. So in this case, the meaning of this question is that when you expand this, okay, you expand this up to, maybe because we are interested in the third terms, you expand this up to the third term, expand this also up to the third term, then, okay, pick the third terms and compare. That is one way. Okay, another way, once you know how to find the general term of any binomial expansion, you can use the general term to find the third term of this. Okay, use the general term of this to find the third term of this, then equate. But I'm not going to go that route. I'm going to look at a situation where we expand this up to the third term, then pick the third term and work with it. Expand this one also up to the third term, pick the third term and work with it. Okay, so let me run through the solution as usual. So you extract what you are given, and thankfully the binomial that we have here, the exponent is positive. So it means if you are quoting the binomial theorem, okay, you quote the one involving combination, okay, for expedience sake. Then what do we come and do again? You check the first term of the binomial is 1. You thank God, you do sign of the cross because you know that though you are going to quote the combination version of the binomial theorem, you quote the special one, which will mean that we are going to write less in terms of quoting that formula. But I have quoted a formula and used the formula mentally. So I didn't quote the formula as usual. 1 plus x to the power n, we know, will be equal to, okay, in terms when your n belongs to a positive integer, we said it to be 1 plus what? N combination 1x plus n combination 2x squared plus what? Your ellipsis plus what have you. Okay, so that's exactly what I am going to do here. So here I compared mentally. I know that my n is 6 and my x is what? 1 over what? Over 2x. Okay, so that is half x. So it means what I have here will be equal to, if I expand, it will be 1 plus 6 combination 1. Okay, then my x to the power 1, okay, which is half, my new x is half x, so I put that in bracket to the power 1. You can ignore the power 1. It's simply understood to be there. Then plus, the next one will be n combination 2. Remember your n is 6, so 6 combination 2. Then x squared, but your x here is half. You put that in bracket squared. And here I'm ending here because of the nature of the question. I'm interested in the third term. So I've gotten to the term that is of interest to me. So I will end there. and represent the rest by ellipses, the rest of the terms by ellipses, plus ellipses. Then I come and do same here with this one too. Power is, okay, what do you call it? Positive. We thank God the power is positive. The first term of the binomial is 1. So it means we can equally quote this formula and use. So if you quote the formula with this one, n is equal to 4, your x is the whole of 4, the px. So you get 1 plus n combination 1. Now n is 4. So 4 combination 1, x squared. But as I say, s squared, x. So x is what? Px. You put that in bracket to the power 1. Or like I said, you can ignore the power 1. Then plus this combination, so sorry, n combination 2, by your n here is 4. So before combination 2, then your x, which is now px, okay, squared. You put that then plus ellipsis. So this one too, you've got into your term of interest, which is what? The third term. So at this point, I'm not interested. I won't go and simplify. So some of you, this is what you did. You moved on to simplify to get the exact term here and equally the exact term here. I won't stress myself because I'm only interested in this term and this term. So now I can come and write, but the third terms are equal. That implies that this third term here should be equal to this third term here. So it is this one that I will come and simplify here. Okay, I won't do any work that is not useful. Okay, so always think before you write as you've been advised. So if you come and simplify this, since combination 2 will give us 15, then this one, if you push the power in, you get half was squared, and half squared is what? 1 over 4. Then what? Your s squared. Then you come and do 4 combination 2, and that's a 6. And this, if you push the power in, you get p squared, s squared. So you finally come and remove your, okay, brackets in each, okay, or on each side. So if you remove your final, your bracket here, you get 15 times 1 over 4 s squared. So you get 15 over 4 s squared. Then 6 times p squared s squared will give us 6p squared s squared. Okay, so at this point, remember we are looking for the value of p. And we have generated an equation indirectly in x and p. But you can see that you have s squared here, you also have s squared here. So that basically means, okay, the coefficient of s squared must be the same. So 15 over 4 should be equal to 6p squared, or better still, you can divide through by s squared. That's the main reason here. Instead of dividing through by s squared, once, okay, this is in s squared, this is also s squared term. For it to be equal, the coefficient must be the same. So you just equate the coefficient, okay, of the s squared, okay, on each side, which gives us this. So now what do? You are looking for p, clear the fraction. If you clear the fraction, we are going to get this. Write it again and divide by 24. Okay, and that's what I did. Only that this time around, I wrote my term of interest, which is what? The p, the term in the p, okay, here. So I had 24 p squared over 24, then 15 over 24. So I had, if I simplify, I'll get p squared is equal to 15 over 24. Remember, we are looking for p. So it means the p, there is a square, we take the square root of that, okay, and we take the square root of this side. But the p that you are looking for, and here, please pass your comments if you have issues. The p that we are looking for, we have sufficient information to say that it's really positive, sufficient information to say that it's really positive. If you are not sure, either direct or indirect, okay, you don't know the information that is giving you this sort of what do you call it? Concept, or this sort of, yes, I should say concept. Okay, what are you supposed to do? Okay, you introduce your plus or minus. So once you are taking the square root, always ask yourself this vital question: do I have sufficient information to say that the quantity is really positive, it's really negative? If it's really positive, then you take only the positive square, which is the principal square root. If your quantity must be strictly negative, then it will be minus root of that. Otherwise, you introduce a plus or minus. It means it can be both positive and negative. So by that, you get P, okay, will be equal to square root of that. Your calculator will give you this, but definitely it will come with a whole lot of decimal, and you are supposed to approximate. And remember, when you are approximating, your first approximation should be 4dp before you come to your convenient approximation. However, those of you who move from this to, when I say convenient, the required approximation, those of you who move from this to your required approximation in this case, okay, that's okay. Only that next time, make sure you move to the 4dp before you come to either the required approximation or your convenient approximation. So at this point, when you approximate, don't forget to indicate your approximation beside. So it will be P will be equal to plus or minus. You take the square root of 15 over 20 for your calculator will give you this. If you convert to, oh, is this 4 dp? This is more than 4 dp. So let me do the needful. Okay, I think it's 5 dp. Okay, pardon me. Quickly, let me go and do the needful. Let me change that one. Okay, there. So that at least I know I think I can even write it here. This is I will change it when I'm sending that to you. Okay, so you let me do it. It's better to do that writing maybe before I forget. Okay, so I've effected the change there. So 4 dp, this is what I have, 0.7906, indicate your approximation. However, we can't end here, remember. Okay, if the question didn't ask us to approximate, then we would have ended by writing, therefore, P will be equal to root of 15 on 24. But even in that one, you know that you don't conclude with a set in the denominator, so you rationalize, or minus, okay, the rationalized form of root of what 15 on 24. Okay, but here, because of the approximation, this is the route that we are supposed to go. So the next one is 3 dp. So you take this one to 3 dp, which will give us what? 0 point. So you count. So first dp, second dp, the third. But you look at the next digits, that is hot. So you add 1 to this. That will give us 0.79 what 1 or minus 0.791. That is 3 dp. I guess my point is well made. If you have any comment, anything, and here the critical thing is this: give me your information. Okay, whether you think this must really be positive or it must really be negative. Okay, and give me your reason. Okay, and we will have that intellectual argument on my YouTube channel. So don't forget to pass your comment. Okay, there. All right. So now let's move on to the question 7. Okay, all right. So quickly, this is what we have in terms of question 7. So this is it. When 1 plus as to the power n is expanded in ascending powers of x. Okay, so we are interested in the expansion being in ascending powers of x. So we underline that. Okay, the series expansion in 1 plus 2s plus. Okay, so obviously this will also guide us. Find the values of n and a. So you can see that this is similar to one of the questions that we handled. I think, yes, it's similar to this. Okay, it's similar to this, only that here you have to be very careful. Okay, so we are going to use the same concept there, only that will give you an extra information. From there, the explanation for that particular question basically will be the same as what we have here. All right, so this is it. With this one, the only note, and okay, because for some of you, or in fact, most of you couldn't untie what that particular knot. Okay, and this indirectly is a question that you should all have seen before. If you are doing a proper thorough work, this was a group assignment, so you should have done all the research. You haven't, I mean, how many of you? Yes, so you could have done a whole lot of research to deal with it. That was expected of you. So I was surprised you couldn't come by, okay, this same question that you have here. It's a well-known question, okay, a familiar question. So in this case, this is the only note in this question is that unlike the previous one, you can see, let's go back to the previous one, the one that I said, okay, unlike this one, you knew the exponent, okay, of your binomial here to be positive. However, with this one, you cannot assume that your n here is positive. It's true, the n can be anything, and because the n can be anything, it can be a positive, it can be a negative integer, it can be a fraction, any number, okay, apart from 1. Please take note. In that situation, you should know that you cannot use the combination. So quote the combination. The combination is restricted. So it means, like I advise, quote that of what? The expanded version of the combination formula. Okay, so you quote this one and you quote the special one of the expanded version because the first term is 1. And I mean this one. Okay, remember we had what? The general one is what? So the expanded version where the first term is 1 and your n is not a positive integer, we said will be equal to 1 plus what? Nx plus what? N into n minus 1 over 2 factorial x squared. Okay, then so that is exactly what I have quoted here. So I shouldn't belabor the point. So you quote this one, then you come and compare. So if you compare, your n is still n, your 1 is 1, and your x is what has changed to ax. Okay, so wherever you see x, you substitute the ax there. Okay, so at this point, you know that is the knot. We've untied the knot. If you use the combination, you will get stuck. You wouldn't be able to deal with it. Okay, so now what do we do? Having quoted the expanded version, you compare and you substitute. And here, if you look at the expansion here in the series, okay, the series expansion, we have the first three terms. So it means this one must be expanded up to the first three terms. So that's where you end and plus your ellipses. So again, but after expanding and simplifying the first three terms, now what do we do? So here you can see that all the terms here will be of interest to you. Unlike the other one that we were interested in the third term, so we picked that. So all the terms in this expansion up to the third term will be of interest to you. So you simplify each of them. Then now you know. But we are told that this expansion here, okay, up to the first three terms will be the same as this. So it means that this expansion here will be identical to this expansion. So at this point, you come and compare coefficients. So if you compare coefficients, obviously the constant term here is 1. This is also 1. So it means the coefficient of x here, okay, which is the NA or AN, if you like, will be equal to the coefficient of x here, 2. So that will give me my first equation. And I've told you, before you label your equation, check if you can clear all fractions, all brackets, okay, and your equation, okay, can be reduced before you label it. So in this case, I cannot reduce the equation, no fraction, no bracket. So I label this as equation 1. And I've told you, don't label your equation this way. Do this and come and write equation, okay, 1. Okay, just do this and write one circle or put it in what? In brackets. Simply read at and understood as what? Equation 1. So in this case, okay, the next one, you compare the coefficient of the s squared. The coefficient of the s squared here is n into n minus 1 over 2a squared. So that's what I have here. And it should be equal to what the coefficient of the s squared here, which is 15 over what? 8. So at this point, I can't label my equation here. Remember, before you label your equation, make sure it is devoid of fractions or brackets. So clear the fractions and remove the bracket. So I could have moved, okay, so after clearing the fraction, you cross multiply to clear the fraction. Once you clear the fraction, then you end up getting this. When you are expanding, I can expand, move from here to here straight away. And most of you should be able to do that as well. So it will be 8n, you multiply the monomials before. So it will be 8n times a, and that will give you 8n a squared, and you come and multiply that by n. But I did that. I did 8n times a squared. Come in, right? I wrote it here. Then I put this binomial. So always multiply the factors with the least number of terms first before you come and deal with the factor with what the more terms. So this is a monomial factor. I multiplied that before I came to multiply the overall monomial factor here by the binomial factor. So that gave me this is equal to that. And I realized that this can be reduced. So I told you, though you have cleared brackets, you've cleared what? Your fraction. This equation can still be reduced. So you reduce before you label it. So you can see that 8, okay, and 30, you have a number that can divide, and that will be what? 2. So 2 can divide 2. Okay, so that gives us this, and that's the point that you label your equation. This is just my humble advice. Okay, so now at this point, what do? We come and okay, work on the two equations. So basically, this is what we are going to do. Okay, so if you look at the equations carefully, we are going to go into the substitution method in solving these two equations. If you listen to the equation carefully, they will tell you as to the best or the ideal method to use, whether the substitution or the elimination. All right, so in this case, I realize that if you are smart, okay, which I know you are, okay, you can see that this each of the terms here has NA or AAN in it. So indirectly, this is what I have. Maybe those of you don't have that eyes. Okay, what you have is the same as 4A. Okay, so 4AN all squared. Okay, minus this, I can also write this as 4. Then I will get what? A out or A n then times n. Okay, so that is what you have there. Obviously, you agree with me that I can express this one in this form. So once I see that, I can see an in the second equation. So I will write equation 2, or sorry, equation 1 into equation 2. And like I said, this will always be too short to take a line. And don't write substitute. Okay, put in. Okay, take note of that. So at this point, what are we going to write? Just write this 1, which is where equation 1 into equation 2, meaning you are putting equation 1 into equation 2, comma. So wherever I say that, just as I've explained, this is the same as what? 4 into an, you know, is what? 2. So wherever I see an, it will be 2. So 2, okay, squared. Then minus 4, okay, and you can see there's 4 times an, okay, times n. So that will give me, okay, what do you call it? Is it times? No, is the, forgive me, is the a that is rather square. So it will be an times a, not times n. Okay, my bad. All right, so at this point, you will get 4 times your an, which is 2, then times your a, and that is equal to 15. So if you simplify this, that will give us 4 times 2 square, which is 4 minus. This time, this will give you 8a is equal to 15. So this will give us 16 minus 8a is equal to what? 15. So I move this one to the side and bring this one here. However, I wrote this side first. So that doesn't mean I maintain it here. I moved in my mind, it is moved. Okay, and this is also moved. So if I move this one, I will get what? 8a. So I wrote that one first. If I move this one to this side, it will be 16 minus 15, and that will give me 1. So what do? You write it again and divide by the 8. Okay, because you are looking for a. All right, so now you come and get what? A is equal to 1 over 8. So you now know your a is left with your n. However, before you can find your n, you will have to substitute the value of a. So it means this equation must be labeled. So you label this as what? Equation 3. Then go and write equation 3 into any of the other two equations, but preferably equation 1 will do, because this equation is prettier compared to this particular one. So at this point, what do? Wherever you see a in equation 1, it becomes 1 over 8. So you substitute, then you get what we have here. So that will give us n into 1 over 8 is equal to 2. Then this one too, you clear the fraction, which is the same, I think the same as n over 8 is equal to 2. Then you clear the fraction, you get n is equal to what? 16 by cross multiplying, meaning you clear the fraction. So at this point, you know the values of your a and your n. But the nature of the question asks us to find the values of n and a. So when you are concluding, you conclude in that order, though the order doesn't really matter. What is important is you've concluded with the values of your n and your a, or your a and your n. So you come and write, therefore, n is equal to 16 and what? A is equal to 1 over 8. Or someone can conclude after getting your a, you can write therefore a is equal to this. After getting your n, you can write therefore n is equal to that. In this case, you concluded with your values separately. With this one, you have done your conclusion with the values what? Together. And in any case, the question asks us to find the two values together. So when you're drawing your conclusion, it will be ideal for you to draw your conclusion together. So that will be it for solution to question 7. Now quickly, let's go and look at that of what? The question 8 and what? And 9. Okay, and question 8, 9, and 10. Okay, these questions deal with what? Or it's all about finding the general term and using it to find particular terms. Okay, so that's all. Okay, so it's that concept, that last concept that we learned in our last lesson. Okay, that we are going to employ here. So quickly, let's look at find the 10th term. So you underline 10th term. All right, so remember when you read question, you make it a habit to underline the salient part. In the expansion of, okay, so we are looking at the 10th term. So those of you who are not familiar with what we are going to do here, you expand up to the 10th term, then pick the 10th term and work with it. But that's not what we are going to do. We are going to deal with the matured and the ideal way, okay, because we know how to find the general term of any binomial and use it to find particular term. So now you write solution after you've underlined the salient part. You write solution. Then what do? Okay, the question number given But the general term of a plus b to the power n is given by, we know that this involves a formula. So we have u sub r plus 1 is equal to n combination r a to the power n minus r b to the power r. You know this formula in our lesson. I think it was lesson 6. Okay, so now what do we have? This implies that if you compare the general term of this binomial in this binomial expansion is will also be u r plus 1 is equal to, now your parameters will be here. Okay, you can see that your parameters will be your a, your b, and your n in this formula. Okay, as for the r, it will change from one specific term or particular term to another. So in this case, I know if I compare, my n is 12, my a is x, and my b is what? Is 3. So take note. So you just come and substitute. When you substitute, you put it in brackets, remember. So that will give us n, which is 12 combination r, okay, a, which is now x to the power 12 minus r, okay, because your n is what? 12. Then in brackets, your, what do you call it? Your b, which is now 3 to the power r. Okay, so at this point, we know that this general term formula or relation that we have here, okay, has the s term standing alone, only one s factor, okay, standing alone. So in this case, if we are looking for a particular term, and this term is a positional term, 10th position, okay, that's the 10th term, the term occupying the 10th position. And remember, I said if you are looking for the 10th or positional term, you use the sum of what? Of the u to determine your r. So for the 10th term, it means, okay, your r plus 1, okay, should be equal to 10. So if you solve, you get your r to be equal to what? 9. So that's what gave me, for the 10th term, r is equal to 9. So it means, therefore, the 10th term will be equal to, you substitute r here in the general term formula for this expansion. So that will give you 12 combination 9. Then in bracket, this will give you 12 minus, okay, 9. And 12 minus 9 is 3. Okay, then into 3 into what? Your r, which is 9. So you use your calculator to find this, okay, which will give us 220. Then you push the power in, which will give us s cubed. You push the power in, which will give us 3 to the power 9, which is this. So now you come and multiply the constant 220 and what? 19683. Okay, that gives you this. Then you attach. Oh, oops. Okay, so this should have been s cubed. So let me quickly do the change. Okay, it shouldn't be s to the power 9. Okay, so that will give us what? X what? Q. Okay, so take note. Quickly, let me do the change. Okay, that's an error from my part. Okay, so I have effected, okay, the change. So now this will be, so it means this is what? The 10th term of this expansion. So you've been able to write or extract the 10th term of this expansion without necessarily expanding everything. All right, so that will be it for question 9. Now we come to question 10. Find the coefficient. So you underline coefficient. Coefficient of which term? Okay, so x to the power 9, y to the power 5 in the expansion. So it means here we are looking for a particular term's, okay, coefficient. So this should tell us that we are supposed to use the general term idea concept in finding the particular term. So again, but given this, okay, so I'm giving this, but we know general term of, okay, any binomial of this form, a plus b to the power n, is given by, okay, what we have here the same way, okay, as we dealt with this one. This implies that the general term of what we are giving, if you compare, you see that your a is 2x, your b is 3y, and your n is what? 14. So you go and substitute. So n, which is 14 combination r, a, which is what? 2x to the power 14, which is n minus r, then b, which is 3y, okay, to the power r. So here we are going to do a little more work. Okay, so unlike the other one that whatever we substituted, okay, we're dealing with the coefficient being 1. So this one, the coefficient is 1. So this one is also, okay, 3 times something. I mean, 3 times 1. And we go number. So with this one, okay, this is what we do. We know, remember I said, make sure if your coefficient of the x, okay, or your variable thing, is not 1, split it using, okay, this law in indices, a to the power a, b to the power m. okay, is equal to what? A to the power m, okay, then b to the power m. So that's what we are going to use. Okay, so at this point, we are going to look at what? This will give us 2 to the power 14 minus r. That's what we have here. And x also to the power 14 minus r by using the laws of indices. And this will also give us 3 to the power r. That's what we have there. Then y times y to the power r. So this simplifies into this. Okay, so at this point, what do we do? I, okay, have another step here. And in this step, you can see that anytime you are writing a term in algebraic expression, you usually will write your constant terms first, followed by factors. You always write the constant factors followed by your variable or variables. So in this case, what do we have? I rearrange, we know that this 3 is a certain power. So this is a constant factor, this is also a constant factor. Any 14 combination, R is also a constant factor provided I know my R. Okay, so I rearrange so that the constant factors will be, okay, will come first, followed by my variable factors. Otherwise, you could have left it here, substituted, and okay, you still end up getting the same result. But in the long run, you rearrange. Okay, so now what do we do? Okay, I'm having rearranged and brought the constant factors first. Okay, we are now going to look at, we said for the term in x to the power 9, y to the power 5. Okay, what do we do? Okay, so y to the power 5. I think this one, the exponent of the x is not that friendly. If I want to use the exponent of the x, I can still use it. So I will do 14 minus r. Okay, should give me the exponent of the y that of the x that I'm looking for is 9. So it means I'm going to get r, if I move this one here, will be equal to 14 minus 9, and that will give me 5. But I didn't use the power of the x because I know the power of the x and the power of the 9. And if you look at the general term here, I can see that the power of the y is prettier. So I use that one. So for you to have y to the power 5, r should be equal to 5. So that will give you the same. So if r is equal to 5 here, you know that your exit power will be 9 as well. So, or you can use the power of the 9. If you substitute, the y will be 5. So, okay, that's it. So now what do? You just come and substitute your r into this formula or relation that we have here, the general, okay, term relation or formula. So you get 14 combination 5 because your r is 5. Then 2 to the power, the 14 minus r, and it will be 14 minus r, which is now 5. So it will be 14 minus 5, which will give us 2 to the power 9. Then 3 to the power r is 5, into, okay, x to the power x, 14 minus r, which will be to the power 9, and y to the power r is 5. So at this point, you are in a pole position, okay, to find whatever that. You can see that here, I didn't write therefore, okay, because the question didn't ask me specifically to find the system. Okay, I know that is the system which will be equal to this, that I will need its coefficient. The question asks you to find the coefficient. Okay, so when you get the term, you extract the coefficient in your conclusion. That's all, or you extract the coefficient and conclude with it. So now this will give you 14 combination 5. Your calculator will give you this. 2 to the power 9, your calculator will give you this. 3 to the power 5, your calculator will give you this. Then you get s to the power 9, y to the power 5. Okay, then now you come and multiply the whole of this, which will give us what we have here. I'm talking about the constants, which will give us what we have here. But the question didn't ask us to find the whole of this term. If you are going to if you conclude with this, you won't get the marks. You know, the question asks us to find the coefficient of, okay, x to the power 9, y to the power 5. So the coefficient of x to the power 9, y to the power 5 is the constant, okay, standard with it. And you draw your, therefore the coefficient of x to the power 9, y to the power 5 will be equal to this. Or therefore this is equal to the coefficient of x to the power 9, y to the power 5. So that would be the solution to question number 9. And now to the last question, which is also interesting. Okay. All right. So with this particular one, if you remember, we've done this. Okay. I think that was the first question, question 1 of the team assignment. In that case, you were asked to expand and give us all the terms. Now, if you look at this question, the question is asking us to find a specific or a particular term. So that term is the fourth term. Okay, so you underline. So I'm not interested in all the terms. I'm only interested in the fourth term. So what do? Again, you use the general to find this particular term, which is what? The fourth term. So given this as usual, by the general term of okay, you have quoted, you come and substitute. So that's what we have here. So again, you compare the general term of whatever you are asked to expand, okay, will be equal to, so now if you compare, your A is equal to 1 over x, okay, your B is equal to the whole of what? The minus, okay, so minus 2 roots of x. Okay, remember, it will be what you are comparing is supposed to be plus, but here it's minus, so we are matured enough. Then your n, okay, is equal to 5. So you are in a good position to carry out your substitution. So it will be 5 combination r into your A. A is what? 1 over s to the power, we said n minus r, so 5 minus r, into, okay, your B. Your B is the whole of minus 2 root of x, all to the power r. Okay, so at this point, your algebra. Okay, so we are going to make use of what? Indices. Okay, a lot here. So this will be equal to, so meaning what I have here, that I should have written u sub r plus 1 is equal to this, but because it is up here, I can choose not to be repeating myself, simply understood to be there. What is equal to this will also be equal to this, equal to that. That's the meaning. Okay, so now what do I do? Okay, if I look at this, in getting my binomial, my x, okay, should appear as a numerator. And we know in indices, anytime you have 1 over a, this is equal to a to the power minus 1. Or if you have 1 over a to the power m, this is equal to, if you bring the a up, okay, as a numerator base, then the exponent must change to negative. Okay, so that's the concept that, okay, I use here. So we know that 1 over x is the same as x to the power negative 1. Then all to this power here. Then this will also give you minus 2. I've told you that make sure that the x is explicit, standing alone, the coefficient is 1. So it will be minus 2 to the power r, then root of x to the power r. But root of x, we know is the same as what? So root of x, you should know, is the same as x to the power half. So instead of writing root of x, I wrote x to the power half or to the power r. Okay, so at this point, what do we have? This will now simplify in terms of indices. If you have a to the power m or to the power n, okay, this will be equal to a to the power mn, remember, in JHS. So that's what I did. So this will give me my x, okay, to what power? Minus 1 times this power. Okay, so minus 1 times this will give me minus 5 plus what? R. But remember, it's better to write the positive first. I wrote R minus 5. Okay, then this will also give me minus 2 to the power R. I will keep that one. Then this, which is x to the power half, or to the power R, the same concept. This will be x, your base, to the power, your exponents or your powers will multiply. So if you have times R, which will give us, okay, half R, that will be the new power of the x. Okay, so in the same way, here you cannot end there because we have, okay, factors which have the same base. This and this, they have the same base, xx. So you can simplify that as one factor to a new base. So in indices again, if you have, okay, x to the power m times x to the power n, that will be equal to, keep your base x, then you add the exponent m plus n. You know that rule. So that's the concept that was used, okay, here as well. So I rearrange, got the constant, okay, first, then the x, so that I can clearly see that they have the same base and different powers, so I can write it as one. So that will give me my common base x. Okay, then I come and add the exponent. Okay, so that gives us what? What do you call it? R minus 5 plus half R. So I'm doing that as a rough word. So R minus 5 plus half R. Okay, so you know that you can call these two alike terms. So it's like 1R plus half R, and that will give you 1.5 R. And 1.5, is the same as 3 on 2. Okay, R. Okay, then minus 5. So that's how come I got this. Okay, I did this, then I ended up getting what is. I did it mentally. I could add this. So that gives you the X now, the new exponent is this. So for the fourth term, you know you are looking for a positional term. And I told you if you are looking for a positional term, okay, how do you get your R? By equating, okay, your R plus 1 here to the term, okay, that you are looking at, the position. So your R plus 1, okay, should be equal to what? 4, the fourth term. So it means R must be equal to 4 minus 1, which is 3. So for the fourth term, R should be equal to 3. So therefore, the fourth term will be equal to, you come and substitute the R into this. So that will give us 5 combination 3 into minus 2 to the power R. R is 3. Then X to what power? The power will be 3 on 2, your R. R is 3 minus 5. Okay, so here I couldn't do it mentally. If you can do it mentally, you can substitute the value there, but I couldn't straight away do it mentally, so I simplified before. So in this case, I'm going to get 10, okay, into, because 5 combination 3 will give us 10, minus 2 all cubed will give you minus 8 if you push the powers in. And this one will also give us x to the power, you are pushing the power in. In actual fact, I simplified before pushing the power in. But you can do the same and combine the two. Simplify, put the power in. So now that will give me 3 times 3 over 2, which is 9 over 2, then minus 5. So that will give me 4.5 minus 5. And I know that that will give me minus half mentally. So it will be s to the power minus half. Okay, take note of that. Or somebody in this is usually will say that don't conclude with a negative exponent. So somebody can write minus 80 over, if you bring the x, which was a numerator, if you bring it down, the power which is negative will be positive. So it will be to the power half. Okay, so let's go back to what we did. Okay, the first question and check. This is just by the way. In actual fact, we are done with the solution here. But I just want to make a point here. So let's go back to the question 1 and see the fourth term there, whether it's the same as what we have here. Sorry. Okay, so question 1, you can see this was it. Okay, this one is the situation where the s is a denominator and it has 4. So 1, 2, 3, 4. The fourth term is what? 80 minus 80 over s to the power half. Okay, if you come to the one that's the s is the numerator, and okay, so if you come to this one too, 1, 2, 3, 4 minus 80 s to the power minus half. So if you go and compare, you see that you will get the same thing. Okay, so take note of that. So this gives us exactly the same thing that we have there. Okay, so in any case, because it's from the same question, okay, question maybe the same set of questions, somebody could have inferred from, okay, question 1, okay, the fourth term will be equal to that. But usually when you are inferring, drawing inference from, okay, one major question to in another major question, we avoid that. If it was maybe question 1A and 1B, that one you can do that from sub questions. But we avoid drawing inferences from a different major question. So take note of that. This is just by the way. So on this note, okay, thank you very much for your attention. And please don't forget to subscribe to my YouTube channel. You see the video there. Don't forget to subscribe to the channel. And again, don't forget to like, share, and pass your comments. And remember, there is one, okay, comment that I'm looking for, I'm waiting for, which is, okay, the one on this that I told you to let us know whether it was supposed to be really positive or really negative. Okay, so we are much grateful. So thank you very much at this point. God bless us all. We are done, okay, with the solution to the entire, what do you call it, team assignment.